Dear students, welcome back. I hope you keep studying. So, today we are going to learn about acceleration of body and equation of motion by graphical method. Acceleration. This is what we say rate of change of velocity. The definition of acceleration of a body is defined as a rate of change of its velocity when time. And if we remember its SI unit is meter per second square and the formula is A equal to V minus U over T, where A is acceleration of body, V is final velocity of body and U is initial velocity of body, T is time taken for the change in velocity. The very first equation of motion, so let me tell you that three equation of motion. This is a graph of uniform acceleration with U as initial velocity and V as final velocity. So we can know very well that acceleration is change in velocity over time. So we can denote acceleration by small a. Change in velocity is difference between final velocity and the initial velocity. Final velocity is denoted by v and initial velocity is denoted by u, and small t is time. So v is meter per second and time in second. So this equation we get at is equal to v minus u. When transfer and exchanger, v is equal to u plus at. This is first equation of motion. Let's move ahead to the second equation of motion. So we have graph of motion. So let's take a situation where object cover a distance s. So distance cover is small s, or we can say just as n in time t under uniform acceleration. So if you look at this graph, we can see this is time represented here. This is velocity v, final velocity, and this is initial velocity u. While working on this graph, we can say distance traveled in area of the figure OABC. So we can find out the area of the shape by finding area of OACD, which is rectangular here OACD. Then area of a triangle ABD, this one. So area of OACD is OA, we have is small u, we can substitute the value of v, OC is small t, we get UT. Here now half OC is again T, so we'll get T and BD is, so this is BD for working out. This BD we can take away CD from the whole BC. So BC is whole in all V and BD is U. So we have take away U, V minus U, and from the very first equation we remember V minus U is 80. So we can write 80 in place of BD. We get this on working out. We get distance travel is small s equal to ut plus half 80 square, and this is second equation of motion. Let's move on to third equation of motion. From the same velocity graph, distance traveled by the object in the time t and moving under uniform acceleration a is given by the AV enclosed by OABC. This whole one. So how can we work out for this again? As is stand distance travel OA plus BC into OC. So by this we can get S is equal to V plus UT over 2. So the first equation of motion is V is equal to U plus AT, or we can say time is equal to V minus U over A. So substituting its value on this one, S is equal to V plus U, V minus U over 2A. So we will get V square minus U square over 2A, and it gives us 2AS is equal to V square minus U square, which is your third equation of motion. Next, uniform and non-uniform acceleration. Uniform acceleration. A body has a uniform acceleration if it travels in a straight line and its velocity increases by equal amount in equal time intervals. Then, non-uniform motion. A body has non-uniform acceleration if its velocity increases by unequal amounts in equal time intervals.